Chapter 7, Part 3, Elimination Reactions. So, elimination reactions are going to build off of that foundation that we've built with SN1 and SN2 chemistry. You'll see a lot of the same players in an elimination reaction, and what you'll learn is that elimination reactions often go hand in hand with SN1 and SN2 chemistry. So, for an elimination, we are not just taking a nucleophile and booting out a leaving group. It's a little bit more complicated than that. Instead of a nucleophile, what we actually need is a base so that we can remove a proton, and the electrons that bound that proton to the carbon will actually be used to create the alkene, and that will cause the leaving group to be kicked out. And in some mechanisms, this is a concerted effort and happens just bam, 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 all in a row. In other mechanisms, this takes place a little more stepwise. The overall effect is that you're losing a hydrogen atom and a leaving group. There are two main types of elimination reactions. The first is dehydration, or the loss of water, and the second is dehydrohalogenation, which would be the loss of a hydrogen atom and a halogen atom. So let's look at dehydration first. This is the loss of a water molecule. That's two hydrogen atoms and an oxygen atom. Notice our water molecule is actually spread out across the molecule. It's not losing water all at once exactly, although this is acid catalyzed, and so it does kind of look like that. So let's take a look at this mechanism. The electrons that hold the hydrogen to the carbon atom are going to be responsible for creating the alkene in our new product. In dehydrohalogenation, you're going to lose a hydrogen atom and a halogen atom. So same thing here, the electrons that hold the hydrogen to the carbon are going to form the alkene, or form the pi electrons of the alkene.